So we just talked about covalent bonds, and the next type of bond we're going to talk about are ionic bonds. But before we get to that, we need to explain what ions are. So an ion is just a charged atom or molecule, and ions have just gained or lost one or more electrons. And ions will either have a positive or negative charge. So example would be like a sodium ion or a chloride ion. And here's another example that you'll find on some of the assignments, and then also could be on the exam as well. So here we've got iron, which the chemical symbol is Fe, and iron has 26 protons and 30 neutrons, and there's also 23 electrons. So what is the ion's charge? So how we figure this out is that we're going to take 26 protons, and then we've got 23 electrons. So protons have a positive, electrons have a negative, so it's like we're subtracting them, and we end up with 3 extra protons compared to the electrons, right? So we're going to have a +3 charge on the ion. Okay, so our iron would have a +3 charge on it. Okay, so that would be our ion. Okay, so ionic bonds, these are just going to be a bond between a positively charged atom and a negatively charged atom. And the key to remember with these ionic bonds is that opposite charges attract each other. So for example, if you have the sodium and the chloride ion, so you've got sodium ion and a chloride ion, that positive charge and that negative charge will attract each other, and they will form an ionic bond between them, and that's going to form our table salt. So here is a salt crystal, and the ionic bonds are actually pretty strong when there's no water around. So if you take a granule of salt, it's pretty hard to crush, okay? But if you put that table salt into water, those ionic bonds will just dissolve, and the salt will dissolve in the water. And what's happening is that when you put the table salt into the water, so like here's our sodium ion with its positive charge, that positive charge is going to attract the polar water molecule. Because remember, the water molecule has these polar covalent bonds holding it together. And remember, oxygen is that electron hog. It's going to pull on the electrons more than the hydrogen atom does, and so you end up with this partial negative charge on the oxygen atom. And so that partial negative charge on the oxygen atom is going to be attracted to the positive charge on the sodium ion. And then the same thing happens with the chloride ion. And instead of the negative charge on the oxygen atom being attracted, it's going to be the partial positive charge on the hydrogen atoms being attracted to the negative charge on the chloride ion. So you can see these water molecules will surround and separate the sodium and the chloride ions from each other, and that will break that ionic bond, and that allows the salt to dissolve in the water. Okay, our third type of bond would be the hydrogen bonds. And a hydrogen bond will be a bond between the slightly positively charged hydrogen atom and another slightly negatively charged atom. And another way we could say this is it's going to be the bond between the partial positive charge on the hydrogen atom and a partial negative charge on, like an oxygen or nitrogen atom. These hydrogen bonds are fairly weak bonds. They're pretty easy to break individually, but if there's many of them, they could be strong overall if you put them all together. Let's take a look at these. So here we've got our water molecule up here, and then down below we've got an ammonia molecule. And if these are mixed together, then they will actually attract each other and form a hydrogen bond between them. So notice that our water molecule, we've got our polar covalent bonds, these straight lines here, holding together the oxygen and hydrogen atoms. And because oxygen's an electron hog, it's going to pull more on the electrons than the hydrogen atoms. So we get a partial negative charge on oxygen and partial positive charge here on these hydrogen atoms. And then nitrogen is also an electron hog like the oxygen is. And so between the nitrogen and the hydrogen atoms, the nitrogen is going to pull more on the electrons that it's sharing with the hydrogen atom, and so they're going to spend more time around the nitrogen than the hydrogen. And so the kinds of bonds that are between the nitrogen and the hydrogen atoms, those are polar covalent bonds as well. So that's what those straight lines are representing there. Those are polar covalent bonds. So we end up with a partial negative charge on the nitrogen. And so these partial positive charges on the hydrogen and the partial negative charge on the nitrogen atom, those are going to attract each other, or if you want to just call them slight positive charges and slight negative charges, they attract each other, and that's going to form a hydrogen bond between the water molecule and the ammonia molecule. And we represent the hydrogen bond as a dotted line because the hydrogen bonds are pretty easy to break. Okay, and then our last bond will be the van der Waals interactions. And these are very weak bonds individually, but they can be strong if you have lots of them. And these are going to be found in nonpolar covalent molecules. And what happens in these nonpolar covalent bonds is that as they're sharing the electrons are moving between the two atoms. And as the electrons move, you're going to get a temporarily positive area and a temporarily negative area. So it's going to be negative where the electron is and positive where the electron is not. And so you get these temporarily positive and negatively charged areas on the molecule. And those temporarily positively and negatively charged areas actually will attract each other on other nonpolar covalent molecules. And because these temporary charges are pretty weak, these nonpolar covalent molecules have to be very close to each other to form these van der Waals interactions. So let me just give you an example of a van der Waals interaction. So we've got nonpolar covalent molecules on the feet of this gecko, and there's also nonpolar covalent molecules in the glass on an aquarium. And if you've ever been to the pet store, you might have seen geckos just kind of suction cupped to the side of the glass aquarium, and they just sit there and they don't fall down off the glass. And what's actually holding them up are many van der Waals interactions between their feet and the glass. And if you have lots of van der Waals interaction, they can actually be strong enough to hold up the weight of the gecko, which is pretty cool.